Hmm. Right. Hello, everybody who's here. Um, the intention of today is to go through the test that everybody did. So as I say, I'm starting with the year nine stuff, and then I will gradually progress to the other stuff. I just need to look for the Q&A. There it is. If you've got anything to say, put it in that box, and I will do my best. But most of all, I will be going through this. I'm going to try and keep it to about half an hour for each one so that I can be done. Um, so let's begin with this. So let's make sure everybody can hear me and see me. Yep, good, fine. Right. If those of you that were here last time will have remembered that I did. Just so you know, so everybody's here. The email that I sent, just to let you know, we are doing the year nine one for the first sort of half hour. Then I'll do the year 10 one, then I'll do the year 11 one. That's the plan, but it'll still be beneficial to everybody. So if you're here, you can follow along to what we're doing. Right. I did mention very specifically that you will get a question asking you about these food tests. And I will tell you that you can get marks for quite a lot of things. The one thing that you want to do for all of these is get your sample of food, grind it up, put it in a test tube with some water. That's what you want to do regardless of which one you're testing for. Then for starch, let's do sugar first. I should do it in that order. For sugar, we add something called Benedict's solution. And the color change that we want to see if sugar is in that food is blue to red. If you said that, you'd be fine. For starch, let's do starch next. For starch, we add something called iodine solution. And the color change that we're hoping to see if there is starch is orange to blue black. Black is enough. You don't have to draw the test tube. No, I was just showing you that that is what you could have said, that you could have, grind up the food and put it in a test tube with some water. That kind of is easy marks regardless of all of them. But really, if you just put the names of the solution and the color change for the three, you'd get all of the marks. The last one was protein. For protein, we add something called burette solution, and the color change that we are expecting to see if protein is present is blue to pink or purple, you can say as well. And that'll be that. The next question said this: emphysema is a disease of the lungs. People who smoke cigarettes are more likely to suffer from emphysema. This shows the lung tissue from a healthy person and the lung tissue from a person with emphysema. They are drawn to the same scale. Now, this is a difficult question. Um, but what you are supposed to realize is that these lines here represent the surface of your lungs or the surface area. Now, the lines that I'm drawing right now are more than the lines that we have here. Okay, because there's much fewer. Think about it. So what we want to say um, is that this reduces the surface area. So there is the person with emphysema, their lungs have a smaller surface area. That's what you must say here. And if they have a smaller surface area, then it means that less oxygen can diffuse into the blood. Okay, less oxygen can diffuse into the blood. Um, There is another mark for also mentioning the thickness of it. So we have a thicker surface over here as well, which means it's harder for oxygen to get across. So not only is it a smaller surface area, it's a thicker surface as well. Um, the question about can you please just touch on the topics of chemistry? And then there's one, two, three, four, five, six topics there. Um, we won't do that today. Other than what comes up in this test anyway. But I'm happy to do that next week. It was the 3rd of February, then you've got some time. Capillaries are blood vessels in the blood which join the arteries to the veins. They have walls which are one cell thick. This is the kind of stuff you should already know. And you would have been asked in the verbal test about arteries, veins, and capillaries. Um, Name two substances that travel from the muscle cells to the blood in the capillaries. Two substances that travel from the muscle cells to the blood. That's a difficult question, right? Because your temptation might be to write something like oxygen. But if we're going from the muscle cells to the blood, what's happening inside your muscle cells? A process called respiration. Respiration on this side of the arrow has carbon dioxide and water. On this side, it has glucose and oxygen, but they're the things that are going into the cells from the blood. This question is about the other way round. So from the cells to the blood, if you'd said these two, you would have got the marks. So the easiest marks are carbon dioxide and water. It is about understanding what the question is asking you and which way the direction of movement is. So from the cells to the blood is like the waste products that the cells don't need. So that's carbon dioxide and water. Glucose is a substance that travels from the blood to the cells. Explain how this happens. So here is a cell. Here is some blood. Glucose moves from here into there. You should know that urea is a answer to that previous question. Yes, it is. I've just given you the two most obvious ones, but there are more answers to that question. Um, so how does glucose move from there to there? You should know that the answer's diffusion, because diffusion is all about the movement of substances across cell membranes. And what you then should say, what diffusion is, you should say that it diffuses across because there is a higher concentration of glucose in the blood and it moves from high to low. Okay. Okay. The higher to low concentration. Thank you. One more thing that I'm going to say to everybody who is on the Zoom call here, which is that you guys may not yet have access to all of this, but you have, as part of you being here, there are videos for every single topic. So whether that's quantitative chemistry or bonding or digestion or respiration, there are videos that are available on our website. You just need a login for them. If you don't have one or don't know what I'm talking about, then get somebody to contact us and I can create a login for you. And then you will be able to see videos that I have personally made on every single science topic and basically every single math topic as well. Some of them are short, some of them are long, but they cover everything you need. So it's a nice place you can go for when you have a test coming up and you need to recap a topic. Everything that you need, including notes, are all in one place. So just contact us about those. Respiration is a process which takes place in living cells. What is the purpose of respiration? Whenever you hear the word respiration, the immediate thing that should come to your mind is the word energy, because respiration and energy are just the same thing. Respiration is the process of releasing energy, and you want to say releasing, okay? So it's to release energy. You can say the word transfer energy, you can say provide energy, but to give energy should be fine as well. But release energy is probably the best one. Okay, so you want us to try and say that. Balance an equation. Well, you may have just learnt this, but by the time you get here, you should have learned that you just put sixes on all of these and it balances the whole equation. That's what you want to put there. What is the name of that substance? Well, if you know what the equation for respiration is, you should be able to figure this out. The respiration equation is glucose plus oxygen gives carbon dioxide and water. So glucose is the answer to that question, of course. Oxygen is absorbed through the alveoli in the lungs. How are the alveoli adapted for this function? The alveoli are those little air sacs. There's millions and millions of them in your lungs. The key features of those, which is a very common question, as proved here, is how are they adapted for moving oxygen in and out, essentially, and carbon dioxide the other way? There are 3 points that basically always work. They have a large surface area. They have thin walls. Um, and you can say that they've got a good blood supply. You can also say moist surface, but I just remember these three. So these three are always an answer to that question. Right, there's some questions here. Um, we're going through the test in this lesson. So if you are in year 9, I'm doing the year 9 one now. I'll do the year 10 one at around 7:30, and I'll do the year 11 one around 8. Name the gas which is excreted through the alveoli. Excreted, somebody asked me this. Excreted means released or given off. It's the waste product. You get rid, stuff you get rid of is what you excrete. So the gas which you excrete is therefore the gas which you breathe out. And that would be carbon dioxide. What is the name of the process of respiration when oxygen is not available? There are 2 types of respiration. There is aerobic respiration when we have oxygen, and there is anaerobic respiration when we don't. And that is what that one is. Describe the process of respiration which takes place in human beings when oxygen is not available. In other words, they're asking you to explain what anaerobic respiration is. That's more or less what this question is asking you for. Now, I would always give the equation here. The equation for anaerobic respiration is just glucose, no oxygen, and then the product is lactic acid and carbon dioxide. Now, I would mention that as the equation because that makes it just a bit easier and you get 2 marks just for putting the equation down. If you mention lactic acid, you would get a mark. There are other things that you can say is that one of the effects of this is that the lactic acid is painful and it hurts. You can also mention that you carry on breathing very hard after you do this, and you get left with something called an oxygen debt, which is where you carry on breathing after you finished exercising. You can even just mention that it's a source of energy. There's a few different things that you can say there, but it's for 3 marks. This is kind of how you could go about getting those marks. Okay. Some digestion. Bread contains starch, protein, and fat. Need to speed up here. Complete each time by choosing the correct words from the box. Okay, it should be easy enough. Amylase speeds up the digestion of starch. The product of this digestion is sugar or glucose. What does it say? Sugar. Protease speeds up the digestion of protein, and the product is amino acids. These things you should know. Why do they need to be digested? So the reason we digest anything is because the molecules are too big, but that would just be 1 mark for saying they're too big. What are they too big to do? They're too big to be absorbed into the blood. In which part of the digestive system does the digestion of starch begin? You should know that amylase is one of the enzymes that's produced by your salivary glands, which means that the digestion of starch must begin in the mouth, where your salivary glands are. And what do we call these things? Well, the entire top, these things that end with A's are called enzymes. I wonder if there was a clue somewhere else. Anyway, it doesn't matter. Enzymes is the answer to that question. The topic is called enzymes and digestion. So, right, that moves on to the chemistry section of the year 9 one. What is the name of the ionic compound shown in figure one? It is sodium fluoride, unfortunately. It's a quite tricky one mark question there, but fluorine becomes fluoride. Chlorine becomes chloride when it reacts. What type of forces? We call these electrostatic forces. When you have positive and negative charges, that's what ionic bonding is. Pluses and minuses attracting. They're called electrostatic forces of attraction. Okay. Two properties of ionic compounds. Again, it's quite difficult, this, especially for you guys, and they're difficult questions, so don't worry too much. Um, you should know that all ionic compounds all have high melting and boiling points. So the high melting point would definitely be one of the answers. And then, I mean, by process of elimination, it won't be low boiling point, because if it's high melting point, it's going to be high boiling point as well. These molecules are not necessarily small, and they're not weak bonds because we've just said that there's electrostatic forces that are quite strong, which leaves you with the top one by eliminating it. These things can conduct electricity, but only if they are in some sort of liquid form, molten or dissolved in water. What happens when a sodium atom reacts with a fluorine atom to form an ionic compound? Okay, sodium is in group one of the periodic table, fluorine is in group seven. And you know that because you had a periodic table. Using just that information, even without these pictures, because you do have some pictures here which help you sort of, you should be able to figure this out because everything in group one, when it reacts, loses one electron to get a full outer shell. So you can say that the sodium loses one electron to get a full outer shell. And then when it loses one electron, it becomes a positively charged ion because electrons are negatively charged. Therefore, when you lose electrons, you're left with an overall positive charge. That would actually get you a couple of the marks. Um, Maybe if you put for a full outer shell, that would be another one. And then fluorine is in group seven. Everything in group seven gains one electron because they've got seven in their outer shell, so they need one more to get a full outer shell. So you'd say that fluorine gains one electron. When it gains an electron, it becomes a negatively charged ion. And once you get to there, you've basically got all four marks. Although you can then say, to be really thorough about it, that these oppositely charged ions, because there's one positive, one negative, they attract together. See what other questions there have been. Um, um, Yeah, you should have been given one separately, but you could have asked for it if not. But you should have. Technically, I'll say you didn't need it for this question because you already had this diagram, but you should have had a periodic table. Um, I think it wasn't printed in the year nine one, but you were supposed to have it. It doesn't really affect anything so far, at least. I'll tell you if it does. Figure two shows the structure of the ionic compound formed in the reaction. What's a limit? It's a difficult question. Quite a lot of people ask me about this question. Um, and the answer is really, really difficult to get. Because look, in reality, what does it look like? It looks a bit like this, basically, where all of these are in like layers and positive and negative ions. This doesn't show you that. So your answer for this one is supposed to say that the diagram is not three-dimensional, which I don't think anybody's going to get, but at least you know now for future reference. It's not three-dimensional. This is a particle of ammonia. This is a very easy question. How many different elements are there in a particle of ammonia? Well, there's just an N and a H, so isn't it just two? The correct name that we give to these kind of compounds that are covalently bonded, when you see this kind of diagram, we call them molecules. And complete the dot and cross diagram for ammonia. Okay, so basically, remember, the idea of this is that these things are meant to get to full outer shells. Now, nitrogen has got five electrons in its outer shell, so it needs three more. Hydrogen has only got one electron, so its only shell it wants one more to make it two. So before we do anything, the hydrogens basically look like this. Okay, because they just got one electron. Now they all want one more, so they're going to share one electron with the nitrogens, but the nitrogen has five in total, so there's one, two, three, four, five. That's the diagram that you're supposed to do there. So what we've ended up with is a nitrogen in the middle that has 8 electrons. It's got the five it had anyway, plus the three more it's sharing. And then the hydrogens have got two because they've got the one that they already had, plus the one more that they're sharing. These are quite difficult questions. Right. State symbols. Okay, well, that's actually no, this is really easy. Your state symbols, just let me just mention this. There's only four options. You can have solid, liquid, gas, and the fourth one is aqueous when something is dissolved in water. In this case, if you just read the question, you cannot lose these marks. Ammonia gas reacts with hydrogen chloride gas. There's your hydrogen chloride. It's telling you it's a gas, so you put a G there. To produce, arrow, a white solid, put an S there, and you've got the marks. Um, and then this is fairly easy as well. They've told you that, well, complete the name of the solid. Well, you can see there's a Cl at the end. You know that when a Cl is at the end, it's called something chloride. So all you were supposed to put was chloride for this answer. Um, I might speed this up a bit. Concentrated ammonia solution gives us ammonia gas. Okay, it's corrosive. Give a safety precaution you should take when using concentrated hydrochloric acid. Um, Gloves, goggles. They're often answers, and they are in this case. Use a fume cupboard. Um, that would be another one that you've seen. Right. Difficult question, this one again, but it's kind of just linked to something else. So when they did this, they saw something appear here. Why did it appear closer to this side than to this side? You see, why was it not like over here? Or why was it not in the middle? And it must be because of how fast these particles traveled. So these particles traveled faster than the other particles. So these were sort of gently going this way. These were rapidly going this way. So that's why you ended up with the meeting further to the left. So you want to say that the ammonia particles traveled faster. Again, with all of these things, it's about getting some practice in. Um, um, yeah, anybody can join whenever you like. But I realistically will try to get to the year 11 stuff around 8 o'clock. But in reality, if you are in year 11, then you should probably still pay attention to what is going on. Because I doubt anybody would know all of the answers to all of these questions. The experiment was repeated at a higher temperature. Why was it produced in less than 3 minutes? Well, you want to say that at a higher temperature, particles have more energy, which means they move faster. When you increase the temperature, you speed up a reaction, and we have a lesson coming up on rates of reaction, I think, fairly soon. What is the pH of sulfuric acid? Well, if it's an acid, it's got to have a pH less than 7. Done. Which acid produces zinc chloride? I think I also talked about this last week, which is that there's three acids that you ever need to know: hydrochloric, nitric, and sulfuric. There are three. And when they react with something, this one produces something chloride. This one produces something nitrate. This one produces something sulfate. And so when it says what acid produces zinc chloride, you should know it is hydrochloric acid. The answer to this question is a little bit harder, but it is when you get an acid reacting with something, the name of the thing that's produced is called a salt. And which compound of these is an alkali? Again, if you didn't know it, but you know it now, which is that anything that ends with hydroxide or oxide is usually an alkali. And that is why that is the answer to that question. It's quite difficult, this one, but if I've got a Cu2 plus ion and an O2 minus ion, then they can just join together. And when one of them joins with one of them, it cancels out the charges. You see what I mean? 2 plus and 2 minus cancel each other out. So just one of each can go together, which means that the answer is just this one. You don't need any other little numbers to change the numbers of that you need because you're just trying to cancel out the charges. A student reacts an acid with copper oxide. It is very slow at room temperature. How could you speed up the reaction? This is a difficult question because you cannot change the temperature because it literally says you are at room temperature. So you can't do that. You have to know the other ways in which to, um, well, you could do something with temperature, but you can't say just increase the temperature. You need to say that you could heat up the solution. So using like a Bunsen burner, heat it up. You could increase the concentration of the acid. That makes the reaction happen faster. And that would be the only two that I would normally say. Okay, and then this is again depending on whether you got round to this, but um, in this experiment, what you do is you keep on adding this copper oxide until there's too much of it, and that is called in excess. So that is the answer to that question. There is a practical on this, which again, I'm not sure whether we all necessarily did, but that's what this is. How do you filter something? Well, you should know that definitely that that is the answer to the question. That the filtering is that process, and then when you produce crystals, you can say crystallization, or you can say evaporation. Okay, I'm just going to answer these questions reasonably quickly. You don't want to say zero for that one. You want to say very small. The mass of a proton is one, neutron is one, electron is very small, and the total number of protons and neutrons is called the mass number. Um, Carbon, I'm going to leave this question because these are just counting things. And this question, relative formula mass of carbon monoxide, it just is the 12 added to the 16, so 28. And then the percentage of carbon in carbon monoxide, well, out of that 28, 12 came from carbon. So you do 12 over 28 and you times by 100, and that will give you the percentage. I'll leave that question. Although people didn't know what an instrumental method was, which I should tell you now. Um, an instrumental method just means using an instrument. Like, for example, if I said to you, what, how warm is it in this room? You might say, oh, it's quite warm, or it's average, or it's above average. But how could you be more accurate about it? You could use a thermometer, couldn't you? A thermometer is an instrument in that example. It is something that gives you a more accurate representation of the value you're measuring. So, for example, again, if you wanted to know how heavy your suitcase is before holiday, you'd put it on an instrument to get the answer, as opposed to just lift it and go, it's roughly, that's reasonably heavy. An instrument gives you a more accurate answer. So that is what we're basically explaining here. I may not do too much of the physics because a lot of it was formulas, which you had, well, basically a lot of it was formulas. That was a thermistor. This was horrible, this question. The dangers of this picture. I will just mention what we can see here. The kind of things you wanted to say that it's hard to even see what's happening here, but you could say something like that there's electrical appliances on the floor that could get wet. You've got these cables running from the ceiling, which is dangerous. You could say that there's wires near water. Yeah, it's not the greatest question because it's not fantastically clear what the picture is saying. Right, what I'm going to do is this solids, liquids, and gases question. Again, if you were there last time, I did say that you need to understand what this is showing you, but in the correct words. So you want to say things like the particles in a solid are tightly packed together, or in a fixed regular arrangement, with very little energy. With a liquid, you want to say they've got a bit more energy and they can slide past each other. With a gas, you can say they move in random directions at random speeds and they're very, very far apart and they've got more energy. This is what the question was referring to when it said things like arrangement, movement, and energy of the particles. If you just follow what it says in the question, it shouldn't be too bad. Yeah, I kind of agree with the picture not being fantastically clear, but it's hard to get too many points on that. But it's okay. Live and you learn. This question on waves, X-rays goes there. One thing I should be tell you is that this electromagnetic spectrum is often written the other way around to confuse you. And in this case, you should never have got it wrong because it's only one missing. But in some cases, I saw some in one of the other ones where because it was written the other way around, it confused people. Um, which one has the most energy? The answer is gamma. The ones at this end have the most energy. Um, Infrared is the answer for the TV remote control. And microwaves travel through a vacuum at the same speed as radio waves. The definition of the electromagnetic waves is they all travel at the same speed in a vacuum. Um, Amplitude is Y, not Z. Be very careful about this. It is from sort of the middle to the top or the bottom. Um, and wavelength would be X if we asked you for that. Another type of transverse wave, you could have said any of the electromagnetic waves. You could have said light, you could have said X-rays, you could have said gamma. Any of those are examples of electromagnetic waves. Um, Frequency is the number of waves produced per second. And the question literally tells you there's 3 waves produced per second, so the answer is 3. And then you have to calculate the speed of the wave using a formula. Is there anything in the maths that I want to do? Laura wants to work out 3% of 1700 and she does this. That is wrong because what that will do is work out 30% of 1700, not 3. What you're supposed to do is multiply by 0.03 to work out 30%, 3%. This one, so you guys with all these tests had a calculator, which actually with a lot of these math questions you wouldn't have normally had a calculator, but we can't really separate it, so we just carried on. What you're supposed to realize for this question, at least without a calculator, is that this fraction, because the top number is bigger than the bottom number, that fraction is bigger than 1. It's like 1 and a bit. Now, 1 and a bit times 60 will give you an answer that is bigger than 60, like 61, 62, or 60 and a bit, which means there's no way you're going to get an answer that's less than 60 if you're timesing 60 by a number that's bigger than 1. That's what you're supposed to do there. But you might have explained it in a different way because you had a calculator. Right. If you increase by 12%, then, oh God, that's a difficult question. Which multiplier can be used with the original value to work it out? If you increase it by 12%, you times by 1.12, the value increased by the same amount of money as in the first year. That is quite a difficult question. The answer to that question is actually 1.24. But that would have been a difficult one to explain and answer because you're increasing by the same amount of money as in year 1. Yeah, that's a difficult one to explain, but move on. In year 1, the value of a card decreases by 12%, then it decreases by 12% again. This time, that would be the answer. That's an easier one to explain because if you reduce by 12%, no, the third option for that first question, the reason it's a difficult question, that first one, is because of this phrase, the same amount of money. It doesn't say the same percentage. If it was the same percentage, that would be it. You'd do 1.12 and then another 1.12. That increases by 12% twice. But because it's the same amount of money, you're effectively just adding on the same number again. So to do that, you could do 1.24. It's a bit complicated, but it makes more sense here because you are decreasing by the same percentage every time. And so if you want to reduce by 12%, you can quickly times by 0.88, and that reduces by 12%. And doing it twice, you times by 0.88 again. A school hall costs £200 to hire. Parents get a 10% discount. 30 parents share the cost equally. How much does each parent pay? Well, if you get a 10% discount, then it is now costing you £180. That's 30 parents divided by 30. So that means each parent is paying £6. Well, seems to be straightforward enough. Here is a cuboid. Work out the volume times those 3 numbers together. This is quite a difficult one, this. A drinks container is a cuboid with a square base. The area of the base is 25. Okay, so if that's an area of 25, it's 5 by 5. And then the volume of the container is 400. Okay, so the volume here is 400. Will the container fit inside the lunchbox? So what we need to do is figure out the height. So if that is 5 and that is 5, then to work out the volume, you would times by this height here. So because I know it's 400, what I can do is 400 divided by 25 and figure out that this is 16. And now the question is, will the container fit inside the lunchbox? Yes, it will. Because we can sort of put it's 16 this way, and then it's 6 deep, so that means that'll fit there. And then its height is also effectively 5. So yeah, it will fit. Yeah, seems to be fine. You just need to figure out that. Did I do 400 divided by? I did that wrong. It was 400 divided by 25. No, I did do that. Sorry. 16. Yeah, yeah, sorry, 16. Fine. So you're trying to get to that 16 so that you can see whether it'll fit one way lengthways. I don't know why that's 4 marks. Um, volume of this is again quite tricky, but you can get some measurements from these areas. So, for example, um, does that work? I'm just trying to put some numbers in to make sure to see if it works. It does. It needs to work for every side. Um, okay. So by because two numbers have to multiply to make all these correct, you can sort of figure out that one's 5, one's 4, one's 3, which creates a box which just by visualizing it, I can see that it will have a height of 3, a length of 5, and then the height of 4. So it's just 3 by 5 by 4. So you're trying to get to the 3, 5, and the 4 to get the answer to that question, and then multiply them together to get the volume. Simplify this. You times the powers together. Now, there are some topics which you will be about to do, you guys who are in year 9, which is indices, but we just threw them in to see what happens. This was meant to be a 2. Um, with this 2, you have to square the 4 to get a 16, and then multiply these powers together to get 16a to the power 10. With this one, you add the powers on the top. 4 add 3 is 7, and then you'll have a 2 on the bottom, and you subtract to get w to the power 5, the answer to that question. Simplify this. 12 divided by 2 is 6. The a's subtract the power. 4 take away 2 is 2. The b's subtract the powers. There's 1 there, so it's 4. And then I won't do that because we're going to cut those out anyway, the last few questions. Right, I'm going to move on to the one that the year 10s did. If this loads properly. Yeah, yeah. Right, okay. And I'll again focus on questions that I think are more important, but I might not write everything down this time. I'll just tell you what's going on. Just speed it up. Uh, Two other substances that the circulatory system transports around the body. An answer that you can't put in this question is blood, which somebody put. I can't remember who. Somebody put blood because the blood is the circulatory system. You can't put that as the thing that it's carrying. You could have said things like oxygen. Um, No, could you have said oxygen? Oh no, you couldn't say oxygen, sorry, because glucose and oxygen are here, so you couldn't say that. You could have said carbon dioxide, water. You could have said hormones. You could have said, I think those are the two easiest answers, but there are a few other answers that you can say. Antibodies and stuff like that. The blood is made up of 4 different parts. They are, no, plasma isn't an answer to that question. I'm just looking at the mark scheme. It isn't an answer to the first question. It is an answer to this question, the components of the blood. It is not a substance that's transported around the body in the circulatory system. The circulatory system is the blood. The blood is made up of 4 things: red blood cells, white blood cells, plasma, and platelets. Now, what you can't do is say that the plasma is a substance that's transported around the body by the circulatory system, because it's like saying that blood is transported by the blood. It kind of doesn't work. It's not on the mark scheme. Can't know anything about that. The heart is part of what type of tissue is the wall of the heart made of? The answer is muscle. The heart is a muscle. Um, I'm not sure what you're saying. Why to other than that? Why can't you say plasma? Is that the question? But because it's part of the blood, it is not something that's transported around by the blood. The circulatory system is the blood. So it's like I'm saying that what if you were driving things around in a car and I said, what kind of things are you carrying? The answer can't be the car, if that makes sense. That's essentially what it means if you put blood or plasma as part of something the circulatory system carries. Um, this question was a I mean, we again, we might do a little bit of adjustment on this because it's a pretty difficult question, especially you can't. I'm going to exclude this information for a minute, and there's a reason for that. It's a bit complicated, but um, the question is basically give the advantage and disadvantage of using a cow valve compared with using a living human heart valve. So, as it says here, it can take many years to find a suitable human donor. So it means that you might be waiting a very long time. This is where, when you do these questions, and it comes only with practice, but you have to add more than what it just says. So if you just say it can take many years to find a suitable human donor, that isn't really going to get you a mark because it doesn't explain what the problem is or what the advantage is or what the disadvantage is. Because it can take many years to find a suitable human donor, and because there are lots of cows, abundant supply of cows, it means that you're waiting for less time. That's the bit that gets you the mark. There'll be less waiting time, right? So this is really important that you understand that you recreating what it says in the question isn't really going to be worth marks. It is about adding a bit more detail to it. Um, So it says here another point that you could have mentioned that it's transplanted during an operation after a donor has been found. This one is attached to a stent and inserted inside the existing fault valve. It tells you that during this operation, the patient's chest is opened up. Um, and here a doctor inserts the stent in the leg. So you can see that the surgery here is less invasive. Because you are managing to do it through the leg, whereas here you're opening up the patient's chest. If you're opening up the patient's chest, there's perhaps more chance of an infection, or you're going to have a longer recovery time because you've opened up the whole body. Um, can you say it's safer? Not on its own. Like you have to be more precise about why it's safer. Just saying it's safer, I wouldn't give that a tick. It's safer. Why is it safer? How do you know it's safer? Like, is it because it's been used for a longer period of time? So that's where this information could come in, which is like how long you've been using it for. That makes it safer. You see what I mean? You've got to apply it to the situation. Other things from your own knowledge, because it does say from your own knowledge as well. You could have mentioned sort of religious reasons with respect to cows. Um, you could also mention rejection. Remember, with any of these things, there's a possible chance of rejection when you get other cells in your body. Perhaps there's more chance of a rejection with a cow than there is with a human. Well, there would be. Um, so these are the kind of things that you could say. But as I say, you'll get other mark scheme for all of these things, so you can check that. Um, Opening the chest, according to the mark scheme, opening the chest is not an advantage. Well, it depends on what you're saying. It's the opening of the chest is an advantage of the cow tissue heart valve. So it is more advantageous for the to use a cow valve because you don't need to be um, opened up. Unfortunately, that is what the answer is. I get your point, which is that they opening it up so they're placing it in the right place, but they'll do that with this as well because they've got advanced ways of doing it. They'll get it to the right place regardless. So that isn't the point. It is the fact that you have a less invasive procedure than opening somebody up by doing that. But I get your point. It's just not on. I can tell you what's on the mark scheme. Um, I didn't make the mark scheme. Um, um, could you say that arteries have thick walls, but valves need thin walls? Um, no, not according to the mark scheme. Again, I can see your sort of point a little bit, but the mark scheme has certain specific points which are kind of around this and the religious reasons a little bit. Um, I'm not sure why the walls would necessarily make a difference either. Yes, arteries have thick walls, but I don't know why that matters. But we can talk about it. The digestive system. Some people got this wrong. Organ A is the stomach, and organ B is the small intestine. Should not be a big issue. This, again, if you have learnt your enzymes and where they're produced, should be a very easy question. Salivary glands don't only produce amylase, they don't produce the other two. The stomach produces protease, it doesn't produce the other two. Pancreas produces all three, small intestine produces all three. Right, this question, which I've marked a few things, and a few people have said the thing that you're specifically not meant to say. How does the acid help digestion? It's nothing to do with um, killing bacteria or breaking down food. Nothing to do with that. It is about providing the right conditions for the protease enzyme, because the protease enzyme is the one enzyme that works best in acidic conditions. So it provides those acidic conditions for the protease enzyme to work. The mark scheme that I'm looking at right now specifically says ignore killing bacteria, ignore acid breaks down food. Nothing to do with that. It is about the conditions for the enzyme. Amylase breaks down starch into sugar, lipase there, proteins there. Um, Diffusion is the answer here. I'm trying to speed this up a little bit. The gas that's breathed out is always carbon dioxide. Um, which cells carry gas B? So gas B is obviously oxygen because we're we breathed in and we're putting that into the blood. So that is therefore the red blood cells for the answer to that question. Um, this one, what you were supposed to do is times 280 by 0.25 and get 70. Again, I marked somebody's recently and they times 280 million by 0.25, but you weren't supposed to do that because it said 1 million alveoli have that surface area. So you've already on a million. If you said pH instead of acidic conditions, will you still get a mark? It depends on how you phrased it. If you said to provide the correct pH for the protease enzyme, then I think you'd be fine. Yeah, the correct pH, yeah, would be fine. Let me see what the mark scheme says. Yeah, accept optimum slash correct pH, then you're fine if you say to provide the correct pH. An athlete trains to run a marathon. The surface area of each athlete's lungs has increased to 80 meters squared, which kind of gives you a clue as to what the answer to this question was a little bit. Give one way in which this increase will help the athlete. If you've got a larger surface area in your lungs, then you can basically get more oxygen around your body. So you want to say more oxygen. You could have said more gas, more gas exchange, more CO2 exchange, but you need to specifically mention that the large surface area means that you'll get more oxygen in. Okay. Describe what happens to protein when you eat it. Um, well, the key things that I would make sure I say here, if we are talking about protein, you want to mention the protease enzyme that breaks it down. You want to mention that it breaks it down into amino acids. You want to say where the protease enzyme is produced. So you can say the stomach, the pancreas, the small intestine. That on its own is probably three of the marks here out of the four. Naming the enzyme, what it breaks the protein into, and where you find it. The only other thing that you probably want to say is what happens to these things once they're digested is that they are absorbed into the blood. You probably don't, it's only 4 marks, so you do need all of them. So absorbed into the blood. In fact, you don't need everything here. You can get away with less. Um, so digested. Yeah, protease enzyme. One of the places where it's made, amino acids gets you a 3rd mark, and then absorbed into the blood gets you a 4th mark. Okay, so that's the way you go about with that one. This one, not many people I've seen so far did this particularly well. This tells you that lipase with an acid doesn't work very well. You want to say why. The question says, explain the results in the table. What some people I've seen did was just basically said what the table says, which is it's lowest when it's with an acid, then it's higher when it's with an alkali or with bile. That doesn't explain anything. It just says what you see. So the reason it's low with an acid is because an acid denatures the enzyme. The reason it's better with an alkali is because lipase works best in sort of alkaline condition or neutral or alkaline conditions. It doesn't work very well in acidic conditions. And then The bile, remember, not only is the bile an alkali and provides those conditions, but bile also emulsifies fats. That was the other thing that bile does. And what that does is it provides a larger surface area for the lipase enzyme to work, which is why we get these bigger numbers with bile and alkalis compared to acids. That's the explanation for it. Right, Ken. Explain why metals can be shaped. I think again, if you were there last week, I specifically said this. It's to do with the layers being able to slide over each other. I'm writing all of this down. Sulfate, sulfuric acid. Describe what you would observe when magnesium reacts with the acid. That's an interesting question. Let me see what the mark scheme says. Um, what you would observe is a gas being produced, you can say. You could mention bubbles. You can mention the magnesium solid disappearing. You can mention it getting hot. That's pretty much it. Um, that's a good question. Why isn't Bile's value higher? Just on that one. Um, I mean, it could be any reason, but the idea is that it's both. They're both high. Um, it could be the amount of bile. It could be that it's too alkaline. Remember, it. Well, actually, I'll tell you why it's not higher. Why it's higher because this is just lipase and bile. Bile's job is to emulsify fats and provide and neutralize the stomach's acidity. Bile works best in sort of pH 7 or 8. Sorry, lipase and amylase work best in sort of neutral slash alkaline conditions, very slightly. Weak alkaline conditions. Bile on its own probably makes it too alkaline. That's probably why it's higher. Um, Fizzing is fine. Um, Hollow. Well, metal. I don't. I mean, from for metals aren't hollow. I don't know what you mean by hollow. Um, what makes it hollow? Um, yeah, no, not hollow. You have to say layers slide over each other. There is no other answer. Um, yeah, fizzing is fine in respect of the I think it's fine. Any indication of bubbles. So fizzing, I would say, is an indication of bubbles. So yes, that will be fine for that one. Um, how could you obtain solid magnesium sulfate? Well, in solution literally means it's mixed with water. So how could you get rid of water? Well, you could heat it to evaporate the water. That's it. You can even say crystallization, but boiling, evaporating the water. This word in solution is so important to remember that it means mixed with water. Um, bit of bonding. Describe how, in terms of electrons, how magnesium and chlorine change into ions to produce magnesium chloride. Well, magnesium is in group 2 of the periodic table. It's got 2 outer shell electrons. So we want to say that this loses 2 electrons. I'm abbreviating things here. When it loses 2, it becomes an Mg2 plus ion. Chlorine is in group 7, which means it will gain 1 electron. When it gains 1, it becomes a Cl minus ion. And then I would add that 2 of these attract with 1 of these so that you get the charges correct. So so you need to say that for the final mark, that we need 2 of these with 1 of those. So 1 mark for saying magnesium loses electrons and chlorine gains electrons. That's 2 marks. Getting the number correct, so 2 and 1. And then specifically understanding that because the charges are different, you need 2 of those with 1 of those. Relative formula mass of magnesium chloride will be 24 plus 2 lots of 35 and a half, whatever that works out to. Draw 13. 1, 2, 8, 3. Doesn't matter how you draw the 3, but 2, 8, 3 is what you need to do for that. Why, again, I explained this. Why are metals good conductors of electricity? You must say either free or delocalized electrons, which can carry the charge through the structure. The mark scheme specifically wants through the structure because that's what conduction is. It is moving through from one place to another. If anybody does have any questions, the Q&A thing is there if you want to put anything in that. Right, this one is just explain how the universal indicators can show, right, well, you can see that because that's red, it tells you that the pH is less than 7. Remember, the question is, how could these universal indicators and the corresponding pH values be used to identify each of these solutions? Well, again, the sulfuric acid is the red one because it has a pH and it has a pH less than 7. Um, Sodium hydroxide is an alkali because it turned purple. It has a pH of more than 7. And then the neutral is green. That's it. It's kind of just saying what you see for that question. Um, right. Acidity is caused by H plus ions. In fact, no, sorry, the name is hydrogen and the formula is H plus. That's what you must say. Um, when you react an hydroxide with an acid, the name of this type of reaction is a neutralization reaction. And they want a balanced chemical equation. It's difficult, but it is. Well, sodium chloride can be made. That's NaCl. Sodium hydroxide can be reacted with hydrochloric acid. Hydrochloric acid is HCl. Sodium hydroxide is NaOH. Oh, and then you're supposed to know that in any neutralization reaction, what is the product? It is water. So we get H2O, and then just check if it's balanced. Yeah, looks balanced to me. Yeah, I think that's it. Um, Show the arrangements for a sodium atom and a chlorine atom. This is easy, right? When you see atoms, it's just what it says on the periodic table. So sodium is 11. So that is 2, then 8, then 1. Chlorine is 17. So it's 2, then 8. That's the maximum. And then 7. And I'll probably ask you about the bonding now. These atoms form different particles by one electron transferring from the sodium to the chlorine. What is the name given to the particles formed? I mean, the answer's earlier in the test. They're called ions. That's what happens when electrons are transferred from one to another. And why do these sodium and chlorine particles bond? It's because there is attraction between the oppositely charged ions, or you can say electrostatic attraction. That becomes a positive, that becomes a negative. The opposite charges attract. Okay. Sodium ion and chloride ion. Yes, you can. I mean, you're doing more detail than you need to for that question because it's just once the general name is an ion. But yes, you can say sodium ion and chloride ion. Yeah. Um, this question we are going to take out when we do this. So I will need to just make a note of that because we're going to take it out regardless because you technically haven't done electrolysis yet. It just ended up accidentally there. Um, so part of the reason I'm doing this is to identify things that I want to take out. Right. Let me speed this up. Um, Again, I'll speed this up reasonably quickly, but this one was how can you meet the UK's commitment to the Paris Climate Agreement? Um, well, the agreement says that we're going to reduce the amount of carbon dioxide, which means we need to reduce our usage of coal and gas because they emit carbon dioxide when we burn them. And we want to increase our usage of energy resources that don't emit carbon dioxide, such as nuclear and wind. That's really what you want to say there. That we're going to use less of the things that produce carbon dioxide and more of the things that don't, um, more or less. Um, on average, there's enough wind to supply everybody. Why do we still need power stations if there's enough wind? Well, it's because wind is unreliable, and there are times when there's more wind and times when there's less wind, so we wouldn't be able to meet demand when the wind speed is low. That's the issue. Um, all European countries in the future, some European will only allow electric vehicles. How is this likely to affect methods of electricity generation in those countries? Well, firstly, we would need to increase the amount of electricity that we're generating. But because we've also signed the Paris Climate Agreement, we cannot use things that emit CO2 like gas and coal. We would have to increase the amount of electricity using nuclear or wind or other renewable energy sources. Um, Advantages of nuclear and disadvantages of nuclear. Advantages of nuclear: lots of energy is produced. It is relatively cheap. It means that we don't use fossil fuels and don't emit carbon dioxide or greenhouse gases. There are loads of advantages to nuclear fuel. The disadvantage is that it produces nuclear waste, which we have to get rid of safely or store it safely so that it's not a danger to the local community. Um, and there's dangers involved to people that live near it. Okay, let's move on. Power is something that's measured in watts, which you are supposed to know, which is why the answer to this question is just 800. There's an equation. I'm not going to do the equation questions because I feel like you should not have any problem with this. Um, but if you do, then please tell me. Be careful on this question. It says the efficiency of the hairdryer in transferring electrical to heat. The heat, they didn't give you the number for it, but you should have realized that if there's 800 electrical and 40 has gone to the fan, then 760 is to the heat. So the efficiency is the useful energy, which is the heat, out of the total energy. And so you do 7060 over 800. These are some circuit symbols. I'm not going to do that. That's obviously X-rays. With any question involving X-rays, you just need to say the same thing every time. Is that X-rays can pass through your skin, but get absorbed by your bone. That kind of is all the time. That's all you ever need. Pass through your skin, absorbed by bone. 2 marks. Microwaves, you should know, and then there's a calculation question. Anything in the maths? There's not a lot in the maths really, because the fact that you had a calculator made this a little bit easier than it should have been. But I'm just going to pick on one of the questions, which was this one. And then that's all I'm going to do for this bit because I think the rest of this hopefully isn't dreadful. And again, we're reducing some of the. We haven't done, for those in year 10, have not done some of the topics on straight line and simultaneous equations. So we're reducing the number of marks on that. So don't stress about it. But the one question that technically you were able to do with some difficulty, this is a hard question, but you could have got some of the marks on it. So this is the last one I'll do, and then I'll move on to the year 11 paper in answer to that question. Also, different people might, when we get to the year 11 thing, some of you might have done a slightly different year 11 paper, but I'm just going to go through the one that most people did. So, and also some people in year 11 might have done the year 10 one. Anyway, what we want to do in this question is work out the area of this triangle ABC. Now, we cannot work out the area of this triangle until we know what this side is. So if you didn't know how to do this question, then at the very least, you could have got some marks for working out let me just take a quick that side, yes, because they've told you that the area of this triangle on the right is 80.5. How do you work out the area of a triangle? You do a half times the base, which is 14, times the height, and that is the height there, right? And we know that that's 80.5, the area. So half times 14 is 7. 7 times h was 80.5, which means that you should have been able to work out that the height was 11.5. So 11.5 was the height there. That much you should have been able to get. The rest of this now, to get the area of this triangle is quite difficult because there's technically a formula that gets you there quickly, but you might not have seen it yet. However, what you are supposed to do is draw a straight line here. To work out the area of this triangle, what do we need? We need the height again. So that's the base, and we need this straight height, don't we? That will allow us to work out the area of that triangle because you need the straight height. Now, because it's the straight height, what I have done here is made a right angle, which means I can work out this. We call this x using trigonometry, which you should be aware of. Then you can work out this side now because that's the opposite, and this is the hypotenuse of that right angle triangle. So using sine 36 is that x over the 11.5, which means that the x, which is the height of the triangle, is 11.5 times sine 36, which is 6.8. And so finally, to work out the area of this triangle, I can do a half times the base times the height that I just worked out. And that will give you the area of the triangle. The maths section, don't worry about too much because there's very little of it that we're going to mark. And the one question that we are going to mark was really, really hard. So Don't stress about it. This one should have been easy because you just have to show it using your Pythagoras rules, and then there wasn't actually anything else that we're going to mark you on for the maths one when we eventually come to mark it. Right, I'm moving on to the test that the year 11s did, which is here somewhere. Um, time we on 8:06. Right, let's do it. Get the mark scheme ready. This diagram shows the position of two glands A and B in a woman. Name glands A and B. So the one near the brain is called the pituitary gland. Apparently, the mark scheme says you can allow hypothalamus. I would never have said that. Pituitary gland. And the ones down here are the ovaries. They are glands because they produce hormones. How does FSH move from gland A to gland B? Well, how does anything? How do hormones? They're hormones, right? The definition of a hormone is it is a chemical messenger which travels in the blood to activate target cells. And therefore, if you know the definition of a hormone, you cannot fail to get this question right because the answer is in the blood. Which hormones produce and release mature eggs? If you know what the different hormones do, this is an easy question. FSH matures an egg, LH releases an egg. Therefore, that has to be the answer to the question. Giving these hormones helps her to produce several mature eggs. Doctors collect the mature eggs from the woman in an operation. Describe how the mature eggs are used so that the woman may become pregnant. Okay, so this is like the people who did the verbal test. We asked you what IVF is, which included the initial process of injecting the female with these hormones and then taking the eggs. Now, this is sort of continuing from then onwards. From then onwards, what do we do with those eggs? We fertilize them. How do we fertilize them? Using sperm. How many marks is this? 3 marks. Fertilize them using sperm. Then this is it's easy to miss this mark. Once you fertilize those egg cells, what do they become? They form embryos. Whenever you talk about this, mention the formation of embryos. It's easy to miss that because you just say, oh, the egg's fertilized, but it forms an embryo. What do we do with those embryos is we reimplant them or insert them back into the mother's womb. And that would be the 3 points that you need. Yeah. IVF clinics have set a target to reduce multiple births. At least 76% of IVF treatment should result in single babies and a maximum of 24% of premature. One reason why the clinics have set this target to reduce multiple births. Well, multiple births means like twins, triplets. They can often cause harm to the mother or to the children and can lead to miscarriages or they can be born prematurely. Any of those are reasons why we might have a target to reduce multiple births. You can also say low birth weight, but some sort of harm to the mother or the child or a miscarriage is enough. Um, this requires a little bit of thinking, this question, but there's 2 clinics and we've got to compare the success rates. Well, what you need to do is work out what the success rate is. The success rate is the successes out of the total, right? So for the first one, it's the success rate is like they've got 200 successful ones out of 1004, which means that the rate is about 20%, 19.9%. The other one is 20 out of 98, which is about 20%, right? So you can say they've got a very similar success rate. They're both about 20%. You can say S is slightly more. Any of those points would be enough. But the point is, the success rate is actually very, very, very similar. The range for clinic R is smaller than the range of predicted success. Why? Well, this has a huge, you see, the predicted percentage success rate is between 3 and 56, which is a huge number, right? Whereas this one's 18 to 23, which is a bit more narrow. And it's because of this number here. Clinic R has done a lot more treatments. It's done over 1,000, whereas that's only done 100. So you want to say that there's much more numbers in Clinic R compared to Clinic S, which allows them to predict more accurately. That's the idea. You can predict better, and this comes to maths and probability as well. You can predict better if you have more numbers to go by, more data, so to speak. Two hormones. I mean, you already knew this, really. FSH and LH. Describe IVF. So, obviously, there's a bit of repetition in this question, but you want to say that I mean, I would have said that you inject LH and FSH first, then you collect the eggs from the ovary, then everything else we said before, which is use sperm to fertilize the eggs, form an embryo, insert the embryo back into the female, and that would be enough. This was meant to be a capital B. Apologies if that confused anybody. Um, a homozygous blue-eyed woman. Right. Blue eyes are the little b. Homozygous blue-eyed means you must be two small b's. There can be no other combination. A homozygous brown-eyed man. Well, homozygous means again the same. If you're a homozygous brown-eyed man, you must have two capital B's. Must do. And so that must be the situation here. There can be no other situation from the words in the question, which means that that is that, that is that, that is that, and that is that. Give the reason why all of the children had brown eyes. Well, because they all contain the dominant capital B allele, or they're all heterozygous, or something, some explanation of that sort of thing, right? The capital letter overrides the smaller letter. The couple's brown-eyed son. Okay, so the couple must their son must have been one of these four. So, okay. And his brown-eyed partner had five children. Two of them had blue eyes and three of them had brown eyes. Show how this could have happened. Well, the partner, in order for some of them to end up with blue eyes, the partner must also have been heterozygous. They must have had a small b, because if that happens, what happens to your diagram here? You end up with a um, blue-eyed child. So that shows how two of their children came to have blue eyes because there was a 25% chance of a child having blue eyes in that scenario. So because they both carried the blue-eyed allele. Okay, this one. Right, this is a complicated question. I'm just going to get straight to the answer because hopefully you remember it. Suggest how scientists could prove that the six types of island fox belong to the same species. There is a definition for the same species. It is when um, there is the ability to breed successfully to produce fertile offspring. So the way you could prove that they all belong to the same species is if they could breed to produce fertile offspring. Okay, the different island types together. That is the definition of the same species. And then I'm going to simplify this answer. It's 5 marks. I appreciate. So what they're saying here is, if you read it carefully, is that the northernmost islands used to be a single island, and the distance between everything was only about 8 kilometers. How could the island fox develop in a completely different species from the mainland grey fox? So basically, what they're saying is that these three islands used to be much closer to the mainland. So what you have to explain is that the mainland fox, whatever it's called, right, will have may have ended up on these islands, and then these islands drifted away. And then you need to mention the conditions on the islands may have been very different to the conditions on the mainland, or different to each other as well. And because of the different conditions, the foxes had to evolve um, differently. So there may have been mutations or there may have been genetic variation under the different conditions. For example, it might have been cold in one place, warmer in another place. Um, which meant that as a result of natural selection, the better adapted ones survived. They reproduced and passed on their genetic information. And then over time, it meant that they got so different to the other species that they become a totally different species because they've evolved differently under different conditions. That's the crucial point here. Um, Suggest why the island fox are developed into different varieties of the same species instead of six different species. Well, that could happen if there were similar conditions on the island, right? So if the islands were very similar conditions, then you would basically stay the same. You see what I mean? You'd have the same species. Um, because you wouldn't need to evolve differently. So that's all to do with that for 1 mark. Right, the chemistry. Electrolyte is something to do with conducting electricity. It's a substance which can be broken down by electric current, or you can mention that the ions are free to move. So a substance that conducts electricity would get you a mark. A substance that splits into different elements by current would get you another mark. So a little bit difficult to get both of the marks there. But what is this? Copper sulfate solution, right? This is quite advanced, these questions, okay? But you guys are supposed to be advanced enough to do this sort of stuff. Copper sulfate solution. You should know that this is made up of Cu2 plus ions. Now, if you didn't know that copper sulfate is, or sulfate is an SO4 2 minus ion, it doesn't matter, but that is what it is. The word solution means that there's water. When you have water and electricity, you get H plus and OH minus ions. There are 4 ions in here. Um, what will happen during this electrolysis is that of the 2 positive ions, the less reactive one will go to the negative electrode. Of copper and hydrogen, copper is less reactive. So we see that at the negative electrode. That is the solid formed at the negative electrode. It is copper. Then, of the 2 negative ions, one of these goes to the positive electrode. And the rule for the negative ions is that if there is a group 7 ion, chlorine, bromine, iodine, then that one will go. Otherwise, the OH minus ion will go. Okay, remember there will always be an OH minus ion if there's solution. It's the other one that changes. That's always there. So the OH minus ion will always go unless the other ion is a group 7 ion. And when this goes to the electrode, we get two products. We get water and oxygen. So when it says the gas given off, the answer is oxygen. If you put carbon dioxide, you would get the mark as well because it can react with the carbon electrode. How could a sample of gas be collected at the positive electrode? Well, what you do to collect gases on these is you usually put a test tube over it, full of water, usually. A test tube full of water is the 2 marks you need. That's what you will have done if you ever observed this in class. Um, so you need some sort of solution, basically. Why does the blue color of the copper sulfate become paler? Well, as I just said, if you've understood this electrolysis, what happened during it? These copper ions all got discharged at the negative electrode. They all went there. And they're the things that cause the blueness in the copper sulfate solution. So because those ions are being removed, we're basically making it less blue because the blueness is being removed. Why is it 2 marks? Uh, Blue color becomes paler. So you want to say that the Cu2 plus ions are removed. That actually gets you 2 marks for some reason. So mentioning the ions and mentioning them being removed is the other mark. That is 2 marks. This question is about electrolysis. Right. The electrolysis of aluminium oxide. Why is it oxygen that's given off and not OH minus? Because OH minus isn't a thing. Um, as an OH minus it's not a thing. It's not a gas. OH minus is an ion. That ion turns when it turns back into its normal elements, it turns into water and oxygen. I mean, there's no such thing as OH. If I said to you, could you breathe in some OH minus? That doesn't make any sense. Because it's not a thing. OH minus and ions turn into water and oxygen. Whoops. So this electrolysis of aluminium oxide, you are supposed to know this again, especially if you're doing AQA. I know I appreciate not everybody is, but it's specifically one of the practicals that's mentioned, but I think it's in all of them. But it's not that complicated. So in the electrolysis, specifically the electrolysis of aluminium oxide, you should know and try and remember it now for the future, which is that they mix something called cryolite into it. The reason they do that is because what they have to do the electrolysis of aluminium oxide is melt the aluminium oxide. They can't mix it with water because it doesn't dissolve in water. So they have to melt it. The problem with with all ionic compounds, as we mentioned earlier, is that they all have a high melting and boiling point. So when you try and melt it, it requires a lot of heat energy. It becomes very, very expensive to the point where it's worthless doing this whole thing to extract aluminium because it's so expensive to melt the thing in the first place. By adding cryolite, what we do is we lower the melting point, which makes the whole process cheaper because we need less energy. So the mixture with cryolite has a lower melting point, which means that we can use less energy to melt it. And that then makes the whole thing cheaper. Don't just say cheaper without saying less energy. Very important. Uh, right. In the electrolysis of aluminium oxide, because we've melted it and we've not added water, there are only two ions. There are aluminium ions, which are Al3 plus, and O2 minus ions, which are there. So there's nothing else. When you have an electrolysis with solution, you have other stuff in there. Um, and this will go to the negative electrode. What will happen to it at the negative electrode? Well, it will gain 3 electrons and turn back into aluminium. That is the half equation. So the aluminium ion gains electrons. So that's what's happened here. The ions gain electrons and turn back into atoms. And then for the oxygen, the half equation, I'll just tell you what it looks like. We have O2 minus turning back into oxygen. It's difficult this if you haven't learned the half equation or if you're uncomfortable with this, but the oxygen loses 2 electrons and turns back into oxygen. But because it's O2, which is a gas, everything gets doubled. And so that's actually the half equation. But then to complicate things even further, what they often do is move the negative electrons to the other side to add them over. So you're left with this as your half equation. If you're uncomfortable with half equations, it's normal. Okay. Explain why the positive electron must be continually replaced. The electrons are made of carbon. The gas being given off in this electrolysis is oxygen. What does oxygen do with carbon? It reacts to form carbon dioxide. Um, and that means the electrode gets worn away, and so you have to keep replacing it. Right. A calculation question. Okay. Calculate the mass of oxygen. Oxygen's here. Produced with 2,000 kilograms of aluminium oxide. The aluminium oxide is there. This is as far as this is a difficult question with all the things involved. Why does the oxygen double in the half equation? Because oxygen is a gas, and it is formed the correct answer is it's formed as a diatomic molecule. But things like oxygen, we say O2. Hydrogen, we say H2. Chlorine, we say Cl2, right? There's an arena and a mobile phone network called O2. We call it O2. So because what's produced has actually doubled, we double everything else. But that's the point. Oxygen, the thing that's produced is O2. So it's not that it doubles, it's just that is what is produced. And so we do it like that. If you're unsure about electrolysis in general, there is a very, very good video produced about it that goes through all of these half equations and sort of takes you through the process of doing it with like 4 or 5 different ones, including this one and the other ones. These are available to you. And I'll just repeat again for those that joined later. If any of you don't have access to the sort of our like online video system thing, that has videos on every single topic, every single one across maths and science, then contact us and I'll just set up your login for it if I haven't done already. Right, back to this question. The overall equation is that, right? So what I like to do in these questions is take out the bits that are relevant, like this and this, okay? Because the question is saying how much oxygen is produced from the aluminium oxide. So I like to just take those out because the rest of it is irrelevant. Then what I like to do is write down the mass in grams of the stuff that we've got. Now we've got 2,000 kilograms, which is incredibly 2 million grams. You don't have to do this. It will still work if you didn't do that, but I would just do it for good practice. Mass in grams is meant that's what to say rather than massing. Um, that's the mass in grams. What you have to do with any mass in grams in any calculation question is convert it to moles. And the way you convert mass in grams to moles is by dividing by the MR. So the MR of aluminium oxide is 2 ALs, which is 2 times 27, plus 3 oxygens, which is 3 times 16. For now, we ignore that number at the front. We will use it in a minute. The MR is 102. So 2 million divided by 102 turns it into moles. And it's 19,607.84 moles. I hope I'm doing this right. 19,607.8 moles. Okay. At which point you now need to look at the balanced equation because what the balanced equation tells you is the ratio of moles from one to the other. So because this is a 2 to 3 ratio, that's why I included those big numbers. It's telling me that the number of moles of oxygen is 1.5 times more than the number of moles of aluminium oxide. So if I've got this many moles of aluminium oxide, then I'm going to times it by 1.5 to get the number of moles of oxygen. That is 29,411. I don't know what. Okay, anyway. Now what we need to do now is turn this back into grams because the question wants it in kilograms. We'll do grams first. And you do that by multiplying by the MR. We divided by the MR to go from grams to moles. To go backwards from moles to grams, we times by the MR. The MR of O2 is 32. So I'm going to times this by 32, which gives me 9411176. That's in grams. Divide it by 1,000 for kilograms, and we get 941. I hope that's the answer. The answer is 941 kilograms to the answer to that question. That's how I would do it. As I say, if you hadn't done the kilograms grams thing, you'd have got 941 anyway. You just would have had some slightly different numbers. But you'd still get to the same thing. But that's how you do that. I would always set it out like that. Mass in grams, MR, moles, and then sort of work your way down that way, then across that way, then back up that way. If you do that every time, don't see how you can go wrong. Right, this one, more complicated. Sodium metal and chlorine gas are produced by the electrolysis of molten sodium chloride. This is so important to read carefully because the electrolysis that you might be more familiar with is the one of sodium chloride solution. Sodium chloride solution means we've added water to it, which changes everything. Molten sodium chloride only has Na plus and Cl minus ions. That's all it has, which means that when you do the electrolysis, you will produce sodium and chlorine. That's it. However, if we use solution, it means that we include H plus and OH minus ions. Now, when we do that, we've got all of these ions now in there. And of the two positive ions, the less reactive ion is the one that will be produced at the electrode. So when it says why we cannot use this to produce sodium metal is because hydrogen is less reactive than sodium. And so hydrogen gets produced at the electrode instead of sodium. And so if we use the solution, we're not going to get any sodium because hydrogen will sort of override it or supersede it because it's less reactive. If you use molten sodium chloride, you will get sodium because there's nothing else in the electrolyte. Um, calculate the volume of 150 kilograms of chlorine gas at room temperature and pressure. Okay, so this basically gives you the clue to what to do here. 1 mole of any gas has a volume of 24. So if I want to work out the volume of this chlorine, I would like to know the number of moles. How do you convert grams to moles? You divide the grams by the MR, which is 71. Do 150,000 divided by 71. That turns it into moles. This is how many moles we've got. And we want to turn that into a volume. It tells you 1 mole of any gas has that volume. So times it by 24 because you've got that many moles and you get 5704. We check the answer to the question. It is that answer. And that would be your 2 marks. Okay. Equilibrium. What is meant by equilibrium? Well, it is when the forward and backward reactions occur at the same rate. Please mention the word rate. Um, and also the third mark, I think it's a 3 mark question. You are meant to say in a closed system. So forward and backward reaction, same rate. I'm abbreviating obviously here. That's 2 marks, right? And closed system gets you the third mark because we cannot reach equilibrium if we've got an open container in which all the stuff is leaving, because otherwise it doesn't re-react back with itself, right? So it needs to do that. Right. Um, so I'm going to say this again for everybody who's listening in year 11, which is that, and year 10, and everybody else, which is that when you get questions on reversible reactions at equilibrium, you basically can only get 3 questions. What is equilibrium, as we just saw? Then you will get a question as to what happens when you change the temperature. Then you will get a question as to what happens when you change the pressure, which is what happened here. That's all you've got. It happens every single time. And the people that I taught, I told them very specifically that that's the only way that you can get asked these questions. Um, so how would increasing the temperature change the yield? Now, this is a little bit tricky, this one, because the answer as to what happens when you change the temperature of a reversible reaction at equilibrium is that the equilibrium moves in the endothermic direction. You get more of whichever the endothermic direction is. And usually the question explicitly tells you which way is endothermic, which way is exothermic. This one didn't explicitly tell you, but it kind of did because of this. It told you that the change of energy here is negative, which means that when we go from left to right, we lose energy. Losing energy or releasing energy means exothermic. It is exothermic that way, which means it's endothermic that way. Okay. So if the question says, what would happen to the yield of ethanol if you increase the temperature? Well, the ethanol's on this side here. If you increase the temperature, the equilibrium will move to the left, which means you'll lower the yield of ethanol. You must say what happens to the amount of ethanol. Don't just say it moves to the left, because that doesn't answer the question. Well, how does that affect the yield of ethanol? It decreases the yield of ethanol. So decrease the yield of ethanol because the equilibrium moves to the left or in the endothermic direction. Something like that. Okay. Um, yeah. And then the only other type of question you get is what happens when you change the pressure of a reaction at equilibrium? Well, let's get rid of these things. To answer that question, you do some counting. You count the number of moles, which are the big numbers on the left-hand side and the right-hand side of the equation. There is one there, there is one there, and there is one there, which means there's 2 on this side and 1 on this side. When you increase the pressure of a reversible reaction at equilibrium, the equilibrium moves to the side with fewer molecules. This side has fewer molecules. So if we increase the pressure, I would say the equilibrium moves to the right because there are fewer gas molecules on that side, which means the yield of ethanol increases in that case. Again, because the question specifically wants you to answer about the yield of ethanol, you must say what happens to the yield of ethanol. So increasing the pressure would increase the yield of ethanol because the position of the equilibrium moves in the direction of the lower molecules. So there's fewer on that side. A catalyst. How does a catalyst increase the rate of a chemical reaction? There's always 2 points to a catalyst. You want to say it lowers, well, the correct answer is, for 2 marks, that we get an alternative reaction pathway with a lower activation energy. I think a lot of people just say lowers the activation energy with regards to catalysts, but it's not just that. It is the alternative reaction pathway, which has a lower activation energy. What time does the lesson end? Whenever you want. You are free to leave. There is no requirement to be here. I can speak to nobody if necessary. Um, Physics. Um, Explain the factors that affect the distance needed to stop a vehicle in an emergency. This is asking you about the things that affect stopping distance. Now, remember, because it's just stopping distance, you can talk about the factors that affect thinking distance and the factors that affect braking distance. Be careful. Not every question is like that. So you can say things like um, anything that affects your reaction time, like tiredness, concentration, drugs, alcohol. You can even say age. You can also say that the how fast you're going affects the distance that you will, of course, stop, right? Of course, the speed is. Then you can talk about things that affect your braking distance, like the condition of the tires, the condition of the road surface, if it's wet or icy, because there's less friction. It's about going into a bit of detail and explaining all of those things because it is an explained question. Um, you've got the formula sheet. Work done is force times distance. Um, well, if you know that work done is force times distance, isn't this relatively easy? Because work done is 900,000. The force is 60,000. Distance is what it is. Divide that over, you should get the answer. Um, explain the possible dangers caused by a vehicle having a large deceleration when it's braking. So, in other words, I mean, there's a little bit of common sense. What happens if you brake suddenly? I suppose that's what it is, right? Like very hard brake. Well, you can mention skidding. You can mention losing control. Um, how many marks is this? 2 marks. Skidding, losing control. The other mark is really hard to get here, but it mentions it brakes overheating or locking. I think it's very hard to get both marks in that question, but one of them should be easy enough about losing control, skidding, that sort of thing. Um, frequency. Oh, again, this is a bit of I'll tell you this now. So if it comes up in your GCSE exam, please make sure you remember the frequency of the UK electricity supply is 50 hertz. It is something you're meant to know. And also, the voltage or the potential difference is 230 volts of your mains electricity supply in the UK. Um, the motor can only be turned when the person using it holds the handle of the motor with both hands. Well, it's because you need to, in order to make this work, you need to close both switches to complete the circuit. Okay, so that the current can flow. Something. There's a formula. I'm not going to do that question. There's another formula. I won't do that question either. A lot of this should be easy enough. Just be careful of units. That's kilowatts, so it's 1,500 watts. Um, there is a formula for something somewhere. Power, energy, and time. There is a formula linking that. So with these questions about looking for the words in the question and figuring out what bits you need and which formula you need to find. This is called the motor effect. To increase the size of the force of the motor effect, you can increase the current or increase the strength of the magnetic field. It's always the same um, stuff that you can say with this sort of thing. This one was a difficult question. I'm not going to go through it for now, but I don't know why. It's a difficult 6 mark question. Um, it requires two formulae. It requires a magnetic flux density formula, and it also requires the moment formula. It is a tough question, which I again may consider seeing what we do with that. It's hard, but it requires two formulae. You're given all the formula sheets. It's just practice of figuring out which ones you need to apply to the situation. I will do just the first couple of math questions because I suspect we're not going to mark you on any of the other transformations. So, um, we need to put 3 coats of liquid on each side of this sail. Okay, so I need to know the area of this shape and then times it by 2 for the other side and then times by 3 for the 3 coats. I think that's what I need to do. The area of this triangle is half times 9.7 times 3.8 times sine 73. There is a formula, a half AB sine C, which gives you the area of the triangle. That is the area of the triangle. So if I want to paint the other side of it, I times it by 2. If I want to do 3 coats of it, I want to times it by 3. And a litre of liquid covers 8.5 square meters. I need to cover 105 square meters. If I divide by 8.5, it gives me 12 and a bit, so I would need 13. Um, I don't know, Lujan, in answer to your functions question just yet. We'll see. I mean, if you get them right, I'll include it. Otherwise, I'm just sort of thinking of excluding it. And lastly, I might just do the functions one if you want to stick around. I might just go through it very quickly anyway. X is an acute angle. Work out the size of angle X. We can only do that. It's a hard question, this. using the cosine rule to work out this side first. Now, in any of these questions with the cosine rule, sine rule stuff, um, use trig. I don't know if you're talking about the first question or the second question. Generally, the answer is no, because these are not right-angled triangles. So you can't usually, unless you do something weird, use trig to work it out. It has to be sine rule, cosine rule, which is not the same as trig, which is a common confusion, just to be clear. I know I'm saying the word sine and cos. It's not the same thing. Um, so whenever you're working out a side or an angle using the sine rule or the cosine rule, you need the thing opposite it. So if I'm working out this angle, I cannot do this without knowing this side. So your first thought should be, you've got to work out this side. So I'm going to work out this side. I'm going to call it y, just for the sake of it. And I notice that I've got, if I know I'm not going to call it y, I'm going to call it a, because then it follows the cosine rule. I'm going to call that a, that b, that c, and this capital A. The cosine rule is a squared equals b squared plus c squared minus 2bc cos capital A. So my a squared is 9.7. Do I need to write this down? No, I won't. We go straight to the calculator. 9.7 squared plus 3.8 squared minus 2 times 9.7 times 3.8 times cos 73. Remember, that is a squared. So you've got to square root it to get what a is, which is 9.3. Call it 9.32 just to be a bit precise, 9.33. And then, now that we've got that side, we can use the sine rule. And sine rule basically means you've got pairs opposite each other. So sine x over 9.33 equals sine 42 over 8. You do a bit of rearranging, you've got the answer. Right. Shall I do it? Shall I do it? Sine 42 divided by 8 times 9.33. And then you've got sine x equals that. So shift sine of the answer is the answer. So that should be the 51 point. I've got the mark scheme up anymore, but trust myself. I'll do this reasonably quickly. As I say, for those, we will be doing this topic in basically the next maths lesson. So the expression for f of minus 1x, the answer is, oh God, what is the answer? It's x over 3, isn't it? Because you divide by 3. If you do this to a graph, you move it 2 units up. And the new equation will be y equals x squared plus 2. If you move a graph up or down, you just add that number to the end of it. What this does to a graph, if you just add a number just to the x inside it, it moves it left and right, but the opposite way to what you think. So a plus 1 actually moves it left. So it's basically like that, with that being at minus 1. What they've done is added 1 to this graph. So to draw the new one, the whole thing will move up 1. So that will go to there, that will go to there, that to there, that to there, that to there. Your new graph will look like this. That's the answer to that question. This one, x plus 90 moves the whole graph left 90. So this point will now come to here. This point will come to here. This point will come to here. This point will come to here. I think. It's basically like that. I've not done that fantastically well, but it's sort of like that. Okay. Right, if we do that, we move a whole graph up 2 units. If we move this up 2 units, the y-coordinate goes to 30. So it's 730. Draw the graph of f of x minus 2. A minus inside moves it to the right 2 units. Be careful of this because it's... No, it's not. Don't be careful. It's easy. Something like that. Oh, gee, that's horrible. Reflected in the y-axis. A reflection in the y-axis. Oh God, I'm trying to remember what this is. Means that your x's become negative. Yeah, so it becomes something like, this is a really hard question. Okay, this requires knowledge of some deep knowledge of this stuff, right? So don't worry too much about it. But that will therefore become minus 3x squared minus 4x minus 5. I think that's the answer to the question. Because your x becomes negative. That's it. That's a reflection in the y-axis. Yeah. Functions. Show that that equals that. Ugh, okay. That is an inverse. So to find the inverse of this function, again, we will do this in the next lesson, is you pretend it says y equals, rearrange it to make x the subject, and then just replace the y that was just subbing in with an x. So it's actually x plus 3 over 2. They put 55 into this. 55 plus 3 is 58. 58 over 2 is 29. So that's what f minus 155 is. We need to show that fg4 is the same thing. So that means put 4 into the g function, which will give you 16. Put that into this function. 16 times 2 is 32. Take away 3 is 29. It is. It works. So you just have to show that properly. Work out the inverse of this. So I'm going to write y equals 2x plus 3 over x minus 4. We need to rearrange this to make x the subject, which is a bit more complicated because of the x is in two places. Let's multiply all of that over. You will get xy minus 4y equals 2x plus 3. I'm going to bring the x's together because I need to make them the subject. So I'm going to have xy minus 2x equals 4y plus, I don't know what that is, 3. Take out x, and you will be left with y minus 2 equals 4y plus 3. So therefore, x is 4y plus 3 over y minus 2. Remember, the y is only subbing in temporarily. You replace the y with an x for your answer. Your answer is 4x plus 3 over x minus 2. Horrible. So as I say, we probably aren't going to include those ones, unless you got them right. I think that's the safest thing to say. Right, I think that's it. That's hopefully all of it. I know I haven't gone through all of the physics stuff, but that's because there's loads of equations. If you have any other questions, just message us and we will deal with it. And a reminder, if you don't have access to all these video things, which you should try and be watching as much as you can, just someone contact us and I'll arrange access for you via our website. Right, that's it. I'll let you go. See you next week.